Med den här apparaten ska jag visa ett intressant.
With this equipment, I will show an interesting phenomenon on unsaturated flow. How a coarse layer diverts the flow in the unsaturated zone. It is a plexiglass tank with outlets in the side walls.
Ett utloppshål borrat på varje sida här. Här och här.
It has a wall between these two parts, up to this level. Above this level, it's open. I will fill the tank with two sand fractions, fine and coarse sand. 8 tensiometers have been installed from the back to measure the water pressure.
Till exempel den här översta
The pressure at this high tensiometer is seen in this tube. This one is seen here, and the lowest one here. Now we have filled the tank, equipped with tensiometers, with two fractions of sand. One rather coarse, particle size about 2 millimeters, and on top of this sand, and on its side, a finer sand. We have layered the sands so that we get a sloping boundary between them. As you saw before we filled the tank, there is a closed wall here to prevent the coarse sand to mix with the fine sand and to separate the outflows from the two sands. Up there is no restriction for the water flow. The tensiometers are located behind these yellow dots. Now we see the pressure as a difference in height between the water level in the tensiometer tube and the level of the tensiometer. So the pressure of this tensiometer is about minus 30 centimeters.
Ett undertryck, negativt tryck. Så att ju högre upp man kommer här.
The higher up we go, the more negative is the pressure. These water levels show the total potential, which is the sum of the height of the measurement point and the pressure. Let's take this one once more. The instrument is at a certain level, and the negative pressure is the distance to the water level in the tube. The total potential is the sum of height and pressure, giving this level. We can see that the tubes to all tensiometers have about the same water level, showing that the total potential is constant throughout the tank. This indicates that there is no flow in the soil, since it is the differences in total potential that generate flow, from high to low potential. This bottle is called Marriott's bottle. It is a way to create a constant water pressure. When air is bubbling from the bottom of the air intake tube, due to water outflow, the water pressure is atmospheric at this level. Above the level, the pressure is negative, and below it's positive. The pressure remains constant when the water level falls, and the flow is constant as long as the tap opening is kept constant. Now we shall see what happens when rainwater infiltrates into the sand in this part of the tank. I open the tap, and water is dripping to the sand. We can see the flow rate on the intensity of the air bubbles in the bottle. Now the pressure increases in the upper tensiometer. The total potential up here increases as the pressure becomes less negative.
Totalpotentialen här uppe ökar från att trycket blir mindre negativt.
So far, no water is coming to the side. Now dripping starts from this side. It is dripping only from the fine sand.
Fin ur sandens sida kan vi säga. Om en liten stund så ska den tensiometer som sitter inne i gruset här strax under gränsen.
The tensiometer in the coarse sand will soon be affected.
Nu börjar den stiga lite.
Now its level starts to rise. We keep this small flow until the level has gone up to this height.
Allt vatten rinner nu genom den.
Almost all water now flows through the fine material. There is a very small water inflow to the coarse sand.
Men väldigt lite. De här stora porerna har svårt.
These big pores cannot fill at this negative pressure of the water.
Den fortsätter att stiga den här lite grann.
This one continues to rise a little. There must have been some water inflow for the water to rise. But it's not the big pores that are filled, but the space between adjacent particles and films around the particles.
Nu har vi ett undertryck på en
Now we have a pressure of about -8 centimeters in the fine sand and about the same in the coarse sand.
större undertryck här.
It is a little more negative here since it has not yet stabilized. The pressure may change gradually or be constant across a boundary like this, but the water content changes drastically, being much higher in the fine sand at these negative pressures.
Två sätt som jag kan få vatten.
There are two ways by which I can make the water enter the coarse sand and start outflow on this side. One would be to tilt the tank to make the boundary horizontal. Then the water supply from above would build a nearly saturated, but not fully saturated zone at the bottom of the fine sand. And eventually, the moisture content would be so high and the pressure so high, but still negative, that water could enter the big pores of the coarse sand, and we would get breakthrough to the coarse sand at some locations.
Men istället så ökar jag vattenflödet nu. Öppna kranen.
But I don't want to do that. Instead, I increase the water flow. I open the tap a little more, and the bubbling in the bottle increases.
Börjar rinna vatten ut här ur grova.
The pressure in both tubes becomes less negative, and water starts to flow from the coarse side.
Centimeters undertryck här.
It is still negative pressure here, about -2 centimeters, and about the same pressure on both sides of the boundary.
Och vattnet rinner.
And the water is now running with full speed out from the coarse sand.
Och jag kan få det här vattnet att sluta rinna genom att minska.
I can stop this outflow by decreasing the water supply from above.
Och det avspeglas i dels att det slutar rinna här.
Resulting in ceased outflow and more negative water pressure.
Förklaras med hjälp av hydraulisk konduktivitet.
What happened can be explained by the hydraulic conductivity and its dependence on water pressure and water content. When the pressure becomes more negative, very few pores are emptied in the fine soil, and the water content remains high. The same pressure decrease in the coarse sand empties these big pores, drastically decreasing the water content. At low pressures, the coarse soil has little ability to conduct water. But with pressures just below zero, and in saturated conditions, the coarse sand conducts water very much better than the fine soil. The saturated hydraulic conductivity is much higher here than there.
Och det där att ett grovt skikt avlänkar omättat flöde, det har betydelse ute i verkligheten.
The fact that a coarse layer diverts unsaturated flow is of importance in a real soil. In glaciofluvial eskers, there are commonly coarse layers of gravel in the sand. When rainwater infiltrates and slowly percolates through the sand in the unsaturated zone and meets a coarse layer, it's not so easy for the water to enter that layer, and the water rather follows the border against the coarse layer along its slope. If it comes to a place where the layer starts to slope upward, a near saturated zone will build up, and now water may enter the coarse layer. It is thus not certain that the unsaturated flow goes straight down in a layered soil. The direction may be governed by the coarse layers.
Nu har jag stängt av flödet här och låter trycken.
I have now closed the flow and allowed the pressures to become more negative as the water flows out on this side.
I den här sidan och tömmer hela lådan. Nu ska vi titta lite grann på rent vertikalt.
Now we will look a little at vertical flow through a homogeneous soil. Let's consider this side of the tank and imagine this as a soil profile. Here are the tensiometers. Number 1, this level, 2, this, and number 3, this level. We have highest total potential up here, as seen by the water levels. Intermediate at the intermediate level, and lowest down here, indicating a downward flow.
Jag släpper på lite vatten här nu.
I add some water at this side. The total potential in the upper increases. The pressure becomes less negative. After a while, the intermediate tensiometer increases. Now it rises. And now also the lowest begins to rise. Now we have a larger potential gradient, seen as a larger difference between the levels, and the outflow increases. I will adjust the flow and wait for equilibrium. Now the levels have stabilized and remain constant. You can see that there is a somewhat bigger difference between these two than between these two. It's the same distance between the instruments, so the potential gradient is larger in the upper part. The reason is that the pressure up here is somewhat more negative, about -4 centimeters. Here perhaps -3 centimeters, and down here -1. This means also that the hydraulic conductivity is smaller up here in the drier soil than further down. For the flow to be constant along the profile, which is the case now, the difference in total potential has to be larger between these two upper points than between the lower, where it's wetter. And this is reflected by the difference in water level in the tensiometer tubes.